Nuclear weapons programs and budgeting. I promised earlier that when you saw the Ivy Mike detonation, you would see the geographic impact it had on the location it was detonated at. If you look at the picture on the left, you'll see the island of Lugalab, and if you look at the picture on the right, it's been completely destroyed. So the critical question with regard to budgeting is, are nuclear weapons cost-effective ways of providing security? In May of 1948, US President Truman decided to put a $14.4 billion ceiling on military spending. Because there was a belief in the inherent cost-effectiveness of nuclear weapons, more bang for the buck, this led to an increase in the proportion of nuclear spending. So the main dispute is over whether nuclear weapons cost 10% or 30% of military budgets. Although this seems very cost-effective, since this cost accounts for 99% of a military's firepower, nuclear weapons are not very flexible. So they have far less politically applicable firepower. Another of the issues is the debate between breeding plutonium or enriching uranium as the cheaper path. Well, the costs are, well, for plutonium it's much more expensive than uranium, though uranium may cost more because it requires more facilities, unless it shares facilities used by a parallel energy program. One estimate puts the production of a critical mass of plutonium at 150 million US dollars. Here in the picture you can see a launch of a Titan ICBM from a silo. So the German case, we have the Luftwaffe, which is the German Air Force, V1 cost 150 British pounds, while the German armies, the Wehrmacht's V2 cost 12,000 pounds. Clearly the V1 was more effective in terms of amount of warhead delivered. It's a question as to either of them were politically effective. The V1 and V2 programs cost, in then dollars, US $2 billion, which is the same price as the Manhattan Project. The V2 cost 50% of a twin-engine bomber. The V1 was only 2%, but both used 50% of the Wehrmacht's explosives. Now, the British case. The British hydrogen bomb was completed in 4 years at comparatively low cost. The British used the plutonium route because it required less fissile material. Research and development was about £30 million a year on the H-bomb, which was about 20% of the strategic weapons spending. 65% of that spending went to delivery means like missiles and submarines and bombers. The British built 1,200 warheads between 1952 and 2001, peaking at 410 at the end of the 1960s with 230 megatonnage, along with 44 tests, of which all occurred at Nevada after 1962. Operating costs of nuclear weapons was about $7 billion between 1981 and 2000. And this ranged between $750 million a year to just $100 million a year in the 1990s. Here you can see a British Vulcan strategic bomber. One of these was used, of course, without nuclear weapons to strike at the Argentinians at Port Stanley, flying out of Ascension Island. So the French case. In 1996, France shut down its 18-missile ICBM force in Le Plateau d'Albion. The French nuclear weapons included IRBMs, ballistic missile submarines, 4 of which operate today, and airdrop nuclear weapons, which we saw earlier with the Mirage 4. The program averaged about 16% of the defense budget since 1970. That seems like actually a very small portion of the defense budget. In the Israeli case, estimates from American observers are that Israel spent in 1950s equivalent dollars, which is a lot of money, 100 to 200 million on the nuclear weapons program, including 25 million for the Dimona reactor. Although France provided the reactor to Israel, the costs of the reactor were borne in part by private donors that were sympathetic to the Zionist cause, such as, for example, the owners of Perrier Water. Now, the Republic of South Africa had a program that was, essentially an energy program that employed about 1,000 people, overwhelmingly employed in the energy program. It cost South Africa an estimated $310 million to build its nuclear weapons. The total cost was thought to be $850 million, with operating costs for about $6 to $7 million a year. Here in the picture you can see a French SSBS IRBM being lifted. Now, the Chinese case. The People's Republic of China nuclear weapons development cost estimate is between the 1950s and 1964 at $28 billion. 37% of the state budget of 1957, and more than all defense spending between 1957 and 1958. So this is the cost of a slow progress nuclear weapons program. It employed several 100,000 people. Direct costs were US $1 billion, and indirect costs were US $2.8 billion, for a total of about $3.6 billion between 1955 and 1964. Though the cost of annual research was about $100 million a year, which is 5% of the defense budget. The Chinese claim to have built the bomb at much lower cost than the Soviet Union. You can see on the bottom left a Qian 5, which is one of the attack aircraft in the older Chinese Air Force, with what I think is a hydrogen bomb that it would have dropped. And you can see a Chinese DF-4 CSS-3 rocket. Now, the Soviet case. The USSR used slave labor, or at least penal labor, in the uranium mines, which provided major cost savings. And there was a labor force of 650,000 Soviets in the 1960s building silos. The US used less than 10% of that because they were mechanized and were much more efficient. The USSR, between 1951 and 1955, the program cost 64.8 billion rubles, or about 10% of the defense budget. By the late 1960s, the RVSN budget peaked at 18% in 1967. Here you can see a SSN-6 soft-fly sea-launched ballistic missile, normally, of course, deployed on a submarine. This is from the Pavel Podvig book, parts of which are in your reader, and you can see here the different missile programs and the different modifications. You don't just build a new missile, you can just modify the one that was there before, and they were under constant improvement because of the rapid pace of technology. And again, you can see the SS-18 that we've spoken out a number of times there in the center, as well as the SS-20, which was the weapon withdrawn as part of the INF Treaty, and the SS-19, which is still deployed today. The SS-18 is still deployed. It's in decreasing numbers every year because it's such an old rocket, and it's manufactured in Ukraine, which of course is not friendly with Russia. So the Russians have not been able to get a replacement of that model. So the US case. We have a chart here of US government spending by function between 1940, which was the beginning of the Manhattan Project, to 1996, about 5 years after the end of the Cold War. The scale here is in trillions of dollars. So you can see that the nuclear weapons infrastructure is about $5.5 trillion, and the national defense budget overall was $13.2 trillion. And you have Social Security around $7.8 trillion, and then income security trails by $5.3 trillion. So the national defense budget and the nuclear weapons budget put together was about $18 trillion. So nuclear weapons spending was about 29% of the total military spending in that period. And nuclear weapons spending was about 11% of all U.S. expenditures for this period. So that's a heavy investment in security. So we can break down the nuclear spending into $400 billion on building the bomb. This is the manufacture of the nuclear warheads. $830 billion on targeting and delivering the bomb. This is delivery systems like rockets and command and control and communications. And so you'll see that missiles are twice as expensive as the warheads, at least. Deploying the bomb was $3.2 trillion. This is salaries, incredibly, and other operating costs like fuel and for vehicles. Defending against the bomb, which was civil defense, and missile defense was almost $1 trillion, $937 billion. And not a lot to show for it. Nuclear waste cleanup was $365 billion, and this is often a hidden cost in the other programs that I cited, where we're looking only at 10%, rather than a 30% proportion or percentage of the total defense spending. And you got $31 billion for nuclear weapons dismantlement. You can see a U.S. Titan missile being launched out of its silo there. So building the bomb. This is 400 billion, but it's broken down between 25 billion in the Manhattan Engineering District. 165 billion was fissile materials production that we looked earlier on, getting the ores, processing them, uranium hexafluoride, getting them enriched. And then 174 billion on weapons assembly, testing, and research and development, which is not unexpected. You have to spend a lot on research and development in order to develop the technology. There are interesting books by Richard Rhodes, one of which won a Pulitzer Prize, and it's the history of the atomic bomb and the hydrogen bomb project. He did a lot of interviews, and there were many technological dead ends, projects that were attempted and failed. So this technology was not immediately obvious at the beginning. So, a subset of building the bomb. The high point of production in the U.S. was 7,000 thermonuclear warheads a year between each year of between 1959 and 1960 and 5,000 in 1961. Thus 19,500 in 3 years, or 25 nuclear weapons a day. The U.S. peak yield was 20.5 gigatons in 1960 with 1,600 bombers, where today the Americans have about 100 bombers, including 940 10 megaton B-36 bombs. Those are the bombs that you saw earlier that looks like giant refrigerators. Some of the sample costs. It costs $191 for a normal 155 millimeter shell versus a $425,000 cost for a nuclear version of that shell. A normal 8-inch shell is $56, and it costs $400,000 for a nuclear version of that. 530 ground-launched cruise missile W-8 warheads cost $630 million, about $1.1 million per warhead, which is actually not that expensive. It's $239,500 is the cost of the non-fissile and non-deuterium components. Thus, costs are mostly the nuclear weapons materials, which have to go through a complicated process. $720,000 is the cost of an advanced cruise missile warhead. U.S. nuclear warhead costs went from $92.5 million in 1948 down to $2.1 million in 1961, mostly because of mass production. However, between 1962 and 1985, the average warhead cost increased 7 to 8% annually because of sophistication. And you can see then the final cost of $37.4 billion in research and development as a part of this category. Research and development, of course, is ongoing on better sea-launched ballistic missile warheads. So here you can see the expenditure on nuclear materials production, and so there's a big push in the early parts because they're looking for very large warheads, and then they discovered because of equivalent megatonnage, you could have smaller warheads, and then a lot of the uranium was simply put into storage and could be used later on because it stores and has a good shelf half-life. Although you still need to generate the plutonium because a lot of the plutonium warheads required replacement. So this is the expenditure for U.S. nuclear weapons research, development, testing, and production, which is, it's not a lot, it's a few $1 billion a year, but you need to make sure that weapons continue to work, and so you take out a couple of weapons to make sure that the quality is still there. Deploying the bomb. This is a total cost of $3.2 trillion. It involved $1.9 trillion on strategic offensive forces, $1.2 trillion on tactical offensive forces, and $51 billion on naval nuclear reactors. And this includes, and here we have the very expensive launching systems, $266 billion spent on 3,160 ICBMs and 2,975 sea-launched ballistic missiles. $227 billion spent on 4,700 strategic bombers, and another $29 billion on strategic bomber research. Today we just have a far smaller number of bombers. $123 billion on 58 ballistic missile submarines. The Pentagon made a request for 100 Polaris ballistic missile submarines, of which 41 were actually delivered between 1957 and 1964. The U.S. currently has 18 of 20 Ohio ballistic submarines that were requested. Each Minuteman costs $1.6 million, which is actually cheaper than a tank, considering this missile has a warhead that can blow up a city. The MX missile was $2.9 million. It's thought it was a lot more sophisticated because it had decoys and had a bus that could move much more efficiently. A B-52 cost $11.4 million each at procurement, although today they probably cost more than $100 million. A B-1B was $16.1 million at the time. 244 were planned, only 100 were bought because they were seen as vulnerable. I showed you a picture earlier of one of those. The B-2A was originally intended to be produced to the number of 132, and because of cost, this was reduced to 75, and then finally, because of the end of the Cold War, it was settled at 20, for a total cost of $45 billion, which comes out to, you can imagine, more than $1 billion per airplane. A Trident ballistic missile submarine cost $49.5 million each. So here's the average unit acquisition cost for a range of different weapons. You can see the B-36 bomber, the B-50 bomber, the FB-111, the B-1B, the B-2, which just goes off the chart, $2.6 billion per airplane. The cost of the MX missile, the cost of the various sea-launched ballistic missiles. So, between 1962 and 1995, the operating costs for the different systems was $93.5 billion for the B-52 fleet, $40 billion for the B-1Bs, and $16.4 billion for the B-2As. $142 billion for the ICBMs, including $101 billion for Minutemen, $12.4 billion for the MX, $18.5 billion for the Titans, $8 billion for the Atlases, and $83 billion for the Trident 1 sea-launched ballistic missile. So current U.S. expenditures are about $25 billion a year on operations and about $10 billion a year on cleanup. In 2000, 14% of the annual U.S. defense budget focused on modernization, which is a very important cost. Nuclear weapons don't cost much in themselves, but you need to modernize them to make sure that they're up to speed. The maximum U.S. arsenal was 32,200 in 1960, and total warheads produced was 70,299 at an average cost of $4.8 million per warhead. And if you consider each of these warheads could blow up an entire city, they're of course incredibly cost effective. So here you can see during the Cold War and the early post-Cold War period, the total U.S. megatonnage and the total number of U.S. strategic weapons. So U.S. megatonnage went down as U.S. strategic weapons went up, but actually U.S. equivalent megatonnage went up. And you can also see there the Soviet-Russian strategic weapon total. And there are different estimates from different authors as to what an appropriate amount of weapons should have been. Here you can see U.S. and Soviet-Russian strategic offensive nuclear forces. You can see the large number of bombers up until the late 50s, early 60s, and they were largely replaced by ICBMs and then MIRVs with the multiple warheads. You can see the rise of U.S. ICBMs as the bombers go down, the rise of U.S. sea-launched ballistic missiles, and they're pretty constant value throughout. You can see the rapid rise of Russian sea-launched ballistic missiles. They're built very, very quickly, as well as Russian ICBMs that were built dramatically after the Cuban Missile Crisis and peaked in 1970, and then you had the sea-launched ballistic missile warheads just explode from the 70s into the late 1970s. So breaking down command and control. So here the total spending was $35 billion, of which $18 billion was spent on DSP satellites, more of which we look at later when we look at command and control and missile defense. $6 to $7 billion on BMUs, which is the Northern Radar System. $1.6 billion on PAVE-PAWS, which are the radars that look over the Pacific and Atlantic coasts of the U.S. $4 billion on nuclear explosive detection systems. $200 million on the bomb alarm system, which is another detection system for detonations on the surface of the continental U.S. And $760 million for additional detectors on Navstar, which is the naval satellites that enable navigation. They also have detectors for nuclear detonations. You can see here a lining up of British Vulcan bombers and China's canceled DF-41 intercontinental ballistic missile in its mobile form. Now, some U.S. economic facts. The U.S. nuclear budget is not by function, like retaliation, limited war ability, so it's very hard to analyze. So there's a disconnect between specific policies and the budget. In the early 1960s, McNamara, the defense secretary, was faced with an Air Force request for 10,000 ICBMs. That's a lot of ICBMs. When it was shown that there's a significant diminishing return after only 450 missiles. There were not enough Soviet targets. An average of 60% of all federally funded research and development was nuclear related in the Department of Defense and the Department of Energy. By the mid-1980s, 30 to 50% of the U.S. aerospace industry was producing nuclear-capable aircraft. That's 550,000 production workers and 650,000 other aerospace engineer workers. Nuclear weapons contracts are usually awarded to a single producer, and subcontractors managed through the Department of Energy and the Department of Defense. And this, of course, raises questions about competition and whether the systems that are being purchased are overpriced. Non-defense spending creates 16% more jobs because defense spending is very capital intensive.